Hello everyone, good day. Welcome to VSPARKZ. Today we are going to see the concepts of scheduling pods using taints and tolerations. We are also going to see a demo on the same as well. If you like this video, please subscribe to VSPARKZ channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. Before understanding the concepts of taints and tolerations, let us first understand why we are going for taints and tolerations. As you all know that we can control the scheduling of pods into the nodes with the help of affinity constraints. This will guarantee only particular set of pods with matching labels will get scheduled only in particular set of nodes that matches those labels. But this will not guarantee that the pods without the matching labels cannot be scheduled in those nodes. That is, even the pods without the labels can also be placed in those nodes. In order not to place the pods onto the inappropriate nodes, we go for taints and tolerations. With the help of taints and tolerations, we can schedule the pods only in the appropriate nodes. Now, let us see what are taints and tolerations. What are taints and tolerations? As you all know, affinity constraints are used to attract pods to a set of nodes. Taints are just opposite of affinity. Taints in the nodes are used to repel the pods. To schedule a pod in the tainted node, we need to apply tolerations to the pods. Tolerations allow the scheduler to schedule the pods with the matching taints. When you taint a node, it will repel all the pods except those that have a toleration for that particular taint. Taints are applied to nodes while the tolerations are applied to the pods. Taints and tolerations work together to ensure that the pods are not scheduled onto the inappropriate nodes. We can apply one or more taints to a node. In order to schedule a pod in those nodes, it has to match all the taints. Let us see how this taints and tolerations works. To make this happen, first we need to taint a node using kubectl command. Kubectl taint nodes, node name, and then the taint attributes. Every taint has a key, value, and an effect as its attributes. In this given cluster, we are going to taint worker node number 2 with the help of this command. Here, the key is app, value is web, and the effect is NoSchedule. Once you apply this command, worker node number 2 will be tainted and none of the pods will get scheduled in worker node number 2. Suppose a pod with this definition, when applied, will be repelled by the worker node number 2 as it has an active taint. This pod will not be scheduled in other nodes as well because the node selector affinity is set which matches only worker node number 2. In order to make this work, a toleration with a matching taint should be mentioned in the pod definition. Just like this. Now, when you apply this definition with the updated tolerations, the pod will get scheduled properly in worker node number 2. So, now you understand these taints and tolerations provide advanced pod scheduling where the tainted nodes control which pods can be scheduled on them. They are easier to manage as compared to other scheduling methods. Taint effects. A taint can have 3 possible effects: NoSchedule, PreferNoSchedule, and NoExecute. Let us see these things a bit more in detail. NoSchedule effect. Let us first see about the NoSchedule effect. Assume that we are running some pods in these worker nodes, just like this. When NoSchedule taint effect is applied in these nodes, it will not cause any problems to the already existing pods. Existing pods remain on the nodes. When we try to create any new pods that do not match the taint will be repelled by the nodes. It may get scheduled onto some other nodes, but in our case, all the nodes have an active taint, and so the pods will go to the pending state. The scheduler will only allow scheduling the pods that have tolerations for the tainted node, like this. So in our case, this Nginx pod will have toleration for the worker node number 2. Now we will see about PreferNoSchedule effect. Again, consider that we are running some pods in these worker nodes. When PreferNoSchedule taint effect is applied, scheduler will try to avoid scheduling the new pods that do not have tolerations for the tainted nodes. But still the new pods can be scheduled onto that node. This is more or less like a soft taint. So as per our existing cluster setup, when this definition is applied, worker node number 2 and worker node number 3 will be selected for scheduling the pods. Worker node number 2 has a soft taint, that's why it still tries to schedule the pod. Whereas worker node number 3 does not have a taint at all. The existing pods remain on the node. Let us discuss about NoExecute taint effect. As usual, consider that we are running some pods in these worker nodes. When NoExecute taint effect is applied, existing pods on the nodes that do not have a matching toleration will be evicted. However, a pod definition with a matching toleration will only be scheduled on those nodes. Toleration seconds, which is an optional field, dictates how long the pod will stay bound to that node after the taint is added. With this definition, the pod will stay bound for 30 seconds post the taints or after the pod creation. Post 30 seconds, the pods will be evicted automatically. But why are we doing all these things? Let us see the use cases of taints and tolerations. Dedicated nodes. If you want to dedicate a set of nodes for a particular set of users, you can add taints to those nodes. Users can add tolerations to their pod definition file, just like this. The pods with the toleration will only be allowed to use the tainted nodes. Special hardwares. If the worker nodes running with some special hardwares like GPU, we need to make sure that the normal pods should not run on those worker nodes. This can be done by tainting the nodes that has these special hardwares. Adding a corresponding toleration will make the pods to run on those nodes which is requiring those special hardwares. Built-in taints. A taint with no execute effect will evict the running pods from the node if the pod has no toleration to it. The Kubernetes node controller will automatically add this kind of taint to a node in some scenarios so that the pods can evict immediately. For example, suppose a node is unreachable because of network outage. It is the best action to move all the pods to a different worker node. The node controller does this action automatically by adding these built-in taints. Now we will see a demo on how the taints and tolerations works. Step number 1, access and inspect the Kubernetes cluster. Access the Kubernetes cluster using kubectl utility and check if the Kubernetes cluster is running properly. Just to save the time, I have consolidated all the commands in a notepad and the same is available in the video description. kubectl cluster info command gives the details of your cluster. Now check the nodes and the pods. Our cluster is running with one master and two worker nodes. Now check the pods in the kube system namespace. Here you can see all the cluster components are running properly. Step number 2, check the taints in the nodes. By default, master node would have been already tainted. This is just to run only the cluster components in the master node. Here you can see the master is tainted and there is no taints for the worker nodes. Step number 3, schedule some default pods in the worker node number 1 and worker node number 2. This is just to check on how the existing pods behave once you apply taints to those nodes. Nginx part 1 is running in worker node number 1, whereas Nginx part 2 is running in worker node number 2. Step number 4, taint the nodes and schedule the pods with tolerations. Here the effect is going to be NoSchedule. Once you apply NoSchedule taint effect, existing pods still continue to run, whereas the new pods with the matching tolerations will only be scheduled on the desired nodes. Before doing that, just execute this tip in order to make the YAML indentations easy in the Vim editor or in the command line. After doing this, you can see the cursor column got highlighted in the CLI. Just try to open a test file and just see if the cursor column is getting highlighted. Yes, it is. Tip is done. Now try to taint the nodes with NoSchedule effect. Check if the taints are applied properly or not. Now create a pod definition with tolerations so that the pod will be scheduled in worker node number 1. In order to do that, execute this command to create a basic pod template and on top of it we can write the toleration definitions. Just remove the unwanted lines from this pod template. Now we need to identify the syntax for the toleration definitions. Let us see how to identify it. Execute this command in another tab so that you will get all the available Kubernetes resources. Try to check for the pods and explain the pod resource template using kubectl explain command. These are all the supported fields in a pod resource template. Try to check the spec field and we can see the tolerations as its subfield. Just explain the tolerations with a recursive operator so that we will get to know the skeleton of it. Yeah, this is the toleration syntax. Now construct the same in our pod definition file in such a way that the pod will be scheduled in worker node number 1. Here the tolerations is an array of objects, so we need to specify in a list format. To specify a list format in the pod definition, we have to use an hyphen in front of it. Here the key is going to be application and the value is going to be web server. So that this pod will be scheduled in worker node number 1. Do a dry run to validate your pod definitions. Once dry run is successful, do apply the same. Here you can see Nginx pod is running in worker node number 1. And also we can see the NoSchedule taint has no harm on the existing pods. Just clean this setup in order to have an empty environment for the next step. But just leave the default pods. That is Nginx 1 and Nginx 2. Step number 5, taint the nodes and schedule the pods without tolerations, and the effect is going to be PreferNoSchedule. Once you apply PreferNoSchedule taint effect, existing pods will still continue to run. New pods, even without matching tolerations, can be scheduled on the node where PreferNoSchedule effect is set, because it is a soft taint. taint the worker node number 1 with PreferNoSchedule effect and the worker node number 2 with NoSchedule effect. So in our case, worker node number 1 has a soft taint. Now create and apply the spot definition which has no tolerations mentioned. So this spot is scheduled in worker node number 1 because worker node number 1 has a soft taint. Again, clean this setup. Ensure taints are removed in worker nodes, and also you have to leave the default pods, that is Nginx 1 and Nginx number 2. Here you can see the taints are removed successfully in worker nodes. Step number 6, taint the nodes and schedule the pods with tolerations, and the effect is going to be NoExecute. Once you apply NoExecute taint effect, the existing pods will be evicted immediately. New pods with the matching tolerations will only be scheduled on the desired nodes. After the optional toleration seconds, new pods will also be evicted. If we want to override this eviction behavior, we have to set the toleration seconds as 0 so that new pods will continue to run forever. Now, taint the nodes with NoExecute effect. By now, the default pods, that is Nginx 1 and Nginx 2, would have been evicted. Create a pod definition which has a toleration for NoExecute effect. Here the toleration seconds is 30. Before applying this definition, check the pods. Here we can see all the default pods are evicted. After applying this definition, Nginx pod is created in worker node number 1. Just wait for 30 seconds, post which this pod will also be evicted. As highlighted already, if we want to override this behavior, we have to set the value of toleration seconds as 0 so that the pod will continue to run indefinitely. Here you can see the pod is evicted after 30 seconds. Well, that's it for this lecture. This is the summary that we have discussed so far in this video. Thank you from VSPARKZ and thank you for watching this video.